Class 9. Subject Science, Physics. Chapter 11. Sound. Topics to be learned in this video: wavelength, frequency, amplitude and speed of sound. Characteristics of a sound wave. The characteristics of sound waves are wavelength, frequency, amplitude, time period and velocity. A sound wave in graphic form is shown in figure, which represents how density and pressure change when the sound wave moves in the medium. In the given figure, see, upper portion of the curve is peak. The peak represents the region of maximum compression. Is called crest. In figure C, the lower portion of the curve is valley. The valley is the region of rarefaction where particles are spread apart, is called trough of wave. Wavelength. The distance between two consecutive compressions or two consecutive rarefactions is called the wavelength, as shown in figure C. The wavelength is usually represented by Greek letter lambda. Its SI unit is meter. Frequency. The number of the compressions or rarefactions that cross per unit time is called its frequency. It is usually represented by V, Greek letter nu. Its SI unit is Hertz, symbol Hz. Time period. The time taken by two consecutive compressions or rarefactions to cross a fixed point is called the time period of the wave. In other words, we can say that the time taken for one complete oscillation is called the time period of the sound wave. It is represented by the symbol T. Its SI unit is second. Frequency and time period are related as follows. V is equal to 1 upon T pitch. The pitch of sound depends on the frequency of sound vibration. It is directly proportional to its frequency. Greater the frequency, higher is the pitch and lesser the frequency. Lower is the pitch. A woman's voice is shrill having a high pitch while a man's voice is flat having low pitch. High-pitch sound has large number of compressions and rarefactions passing a fixed point per unit time. Amplitude. Magnitude of the maximum disturbance in the medium on either side of the mean value is called the amplitude of the wave. It is usually represented by the letter A. Loudness and softness of sound. The loudness and softness of a sound is determined by its amplitude. Greater the amplitude of sound wave, greater is the energy, louder the sound. Short is the amplitude, less is the energy, soft is the sound. Loudness and softness of sound is measured in decibel dB. Timbre or quality of a sound. The quality or timbre of sound is that characteristic which enables us to distinguish one sound from another having the same pitch and loudness. A sound of single frequency is called a tone. The sound which is produced due to a mixture of several frequencies is called a note and is pleasant to listen to. Noise is unpleasant to the ear. Music is pleasant to hear and is of rich quality. The speed of sound. The speed of sound is defined as the distance which a point on a wave, such as a compression or a rarefaction, travels per unit time. We know speed, V is equal to distance upon time, is equal to lambda upon T. Here lambda is the wavelength of the sound wave. It is the distance traveled by the sound wave in one time period, T, of the wave. Thus, V is equal to lambda into nu. Because 1 upon T is equal to nu. Speed of sound V is equal to lambda into nu. That is, speed is equal to wavelength into frequency. The speed of sound remains almost the same for all frequencies in a given medium under the same physical conditions. Example: a sound wave has a frequency of 2 kHz and wavelength 35 cm. How long will it take to travel 1.5 km? Solution: given frequency nu is equal to kHz is equal to 2000 Hz. Wavelength is equal to 35 cm is equal to 0.35 meter. We know that speed v of the wave is equal to wavelength into frequency. V is equal to lambda into nu is equal to 0.35 meter into 2000 Hz. We get 700 meter per second. The time taken by the wave to travel a distance, d, of 1.5 km is t is equal to d upon v, 1.5 into 1000 meter upon 700 meter per second. 15 upon 7 is equal to 2.1 second. Thus sound will take 2.1 second to travel a distance of 1.5 km. Intensity of sound. The amount of sound energy passing each second through unit area is called the intensity of sound. We sometimes use the terms loudness and intensity interchangeably, but they are not the same. Thanks for watching. Please like and subscribe my channel.